Good evening, friends. In today's class, we will discuss about the voltage and reactive power control. So, in this chapter, we will discuss about what is the reactive power and what is the importance of the reactive power in the power system network. Also, we will discuss what the correlation that we have between the voltage and as well as the reactive power. Okay, and apart from this, how to control this reactive power in the power system by making use of the various devices that we are going to discuss mainly. Okay, so this total model which mainly consisting of what are the components which going to be affect the reactive power, and similarly what is the relationship between the voltage and the reactive power. Similarly, what is how we are going to save the amount through this reactive power compensation. It means the economic in order to supply the electrical power for the load consumers, how this reactive power which plays an important role in the power system network, and due to which there will be a cost saving, how it is to be done, that we are going to discuss. And apart from this, we are going to discuss about the voltage control by the reactive power injection, that is by making use of the various devices such as shunt capacitors, series capacitors, and synchronous condensers, and by making use of the various fast devices, how the voltage control by the reactive power injection is to be done, that we are going to discuss. So first, let me briefly explain the introduction about this reactive power. Actually, in the previous modules, we discussed about the load frequency control. So there, how the load frequency is going to be maintained constant, both in the case of isolated systems, similarly in the single area systems, and as well as in the two area systems, how it is obtained, we have discussed. So in that entire process, by where we are maintaining the constant frequency, that is load frequency control, in the case of single area and two area system, we have taken the active power generation into the consideration. It means the total load frequency control, which entirely depends upon the amount of real power generation and the load demand. It means if there is a load demand and real power generation both are in equal value, it means whatever the load demand which we have at a particular instant, if it is supplied by the generators which have been connected, so then the frequency is going to be maintained constant. In case there is a mismatch between the amount of power generation and the amount of load demand, then the frequency mismatch will come into the picture. It means whenever the load demand is more than the amount of power generation, then the frequency will be decreased to the normal frequency. Normal frequency in our country, we are maintaining it as a, that is a standard frequency, we are saying it as 50 hertz of the frequency. So whenever there is a demand in more in value while compared with the power generation, the frequency will be decreased. And similarly, when the demand is less while compared with the power generation, obviously the frequency will be get increased. There is a indirectly proportionality between amount of power generation and as well as the frequency. There is an increase in the load demand which will decrease the frequency, and similarly decrease in the load demand which will increase the frequency. So during this process, that means that entire load frequency control, which entirely depends upon the active power generation or the real power generation and the real power demand only. And during this process, we consider that the voltage at the various buses which are going to be maintained constant. So how this voltage is going to be maintained constant? And in that process, we just consider that by making use of automatic voltage regulators, we are maintaining the voltage at the specific bus, which is going to be a constant. But usually, uh, this voltage, which that we need to take into the consideration while we are discussing about the reactive power. So in this chapter, we will take into the reactive power into the consideration, and using which how the voltage that will be get controlled in the practical power systems, that we are going to discuss, right? So this we can for first, before going to discuss in detail about this relation between reactive power and the voltage, first let us discuss what are the various elements in the power system network that will produce the reactive power, and similarly what are the various elements in the power system network that will absorb the reactive power. So the elements are the devices which produce the reactive power, which will act as a source for the reactive power, and similarly whatever the devices in the power system network which will observe the reactive power, which will act as a sink of the power system network. That means which produces the reactive power is called as a source of the reactive power, which absorbs the reactive power, which is going to be called as sink of the reactive power. So now we will see what the power system network practically consisting of, and individually how it will influence the reactive power that we are going to discuss now. So any power system network that if we take, it mainly consisting of the synchronous generator firstly, and after that transformer. That is whatever the power which we are generating by making use of the synchronous generator, it will be get step up to the various levels of voltages based on the requirement, and that step up to the power which is a step up at the generating station, that will be get transmitted to the various local areas using the transmission system. And after that, again from whatever the power which is received from the transmission network, again it will be get stepping down to the various levels of voltage, and then using the distribution system, that is the distribution network, we are going to distribute the load for the various load centers. This is what the general process that we have. So if you consider the total or entire the power system network, it is the combination of synchronous generator, transformer, transmission network, and loads. Okay, so firstly we will take the synchronous generator. So how this synchronous generator, either which will it will act as a source of the reactive power or the sink of the reactive power, that we will see, and how this process that is going to be done. Okay, so the synchronous generator, which in generally called as a doubly excited machine. Synchronous in the most of the applications in our power system, we are generating the electrical power by making use of the synchronous generator. That is either hydro systems if you take, or thermal systems if you take. We are using the synchronous generators. We are using them. Okay, these synchronous generators are called as doubly excited generators. So one excitation which we are giving it as mechanical excitation, and that mechanical input is get converted into the electrical power, and the another excitation we are giving for the synchronous generator is field excitation, which is responsible for the production of the magnetic flux and as well as the reactive power. So based on the type of excitation which we are giving as input for the synchronous generator, it depends which type of it is going to be active. It means if you give the over excitation for the synchronous generator, then it will act as a source of the reactive power. It means whenever the synchronous generator is supplied with the over excitation, then the synchronous generator develops or generates the reactive power, and it will delivers to the load. So always a over excited synchronous generator will act as a source of the reactive power. We can say like this. And the under excited synchronous generator, always it will consume or always it absorbs the reactive power. So an under excited synchronous generator always said to be a sink of the reactive power. So this how this is explained here. So the synchronous generator, they can either absorb or generate the reactive power depending upon the excitation. So based on the excitation only, either the synchronous generator absorbs or generates the reactive power, it will be get dependent. So whenever the generator is over excited, it is the generator terminal voltage, which is the generated voltage is greater than the terminal voltage, and it will inject the terminal bus which lacks the terminal voltage, and therefore an over excited generator which always acts as a source of the reactive power. Okay, and similarly an under excited synchronous generator which will act as a sink of the reactive power. Just a small conclusion that we can make here: a synchronous generator which is having two types of excitation, that is over excitation and under excitation. Always the over excitation synchronous generator which will act as a source of the reactive power, and the under excited synchronous generator which always acts as a sink of the reactive power. That's it. Next. So this over excitation and under excitation that can be explained betterly with making use of these two vector diagrams. See, this is the terminal voltage V. In the case of under excitation, the first diagram which explains the over excitation, the second diagram which explains the under excitation. So in the case of over excitation, the current which is lag behind the terminal voltage V, and this I into Xs which represented as the voltage drop due to the synchronous reactance. In this case, the drop due to the resistance is neglected. So if you add this terminal voltage and the amount of voltage drop due to the synchronous reactance, then the resultant vector which denotes the amount of EMF generated. Okay. And in the case of under excitation, the current which is going to be leads, and this represents the voltage drop into the reactance. And if you add this, then the resultant vector which gives us the generated voltage of the synchronous generator. Right. Now, the another important device in the power system network is overhead lines. So, the surge impedance of the overhead transmission system, which is given by the characteristic equation it has, that is the surge impedance ZS, which is given by square root of L divided by C, where Z is nothing but the amount of surge impedance, and where L is nothing but the amount of inductance, and the C is nothing but the amount of shunt capacitance of the transmission system or overhead line system. And similarly, the amount of surge impedance loading which is given by V square divided by Z, where Vs is nothing but the amount of rated voltage, and amount of Zs which represents the amount of surge impedance. So how this surge impedance loading which depends upon the or which influences the reactive power. So here two types of surge impedance loading will be possible. So whenever the load is less than the surge impedance loading, and whenever the actual load onto the power system network is greater than the surge impedance loading. So whenever the sorry, whenever the load below this surge impedance loading, then the transmission line which generates the reactive power, and due to resulting in the receiving end voltage which is greater than the sending end voltage. And whenever the loads greater than the surge impedance loading which you will have, in that case, always the load which will takes or absorbs the reactive power, and in this case, it will take the reactive power. So in this way, the transmission or overhead lines of the given power system network, which influences the reactive power. So simple conclusion that we can make here: whenever the actual load onto the power system network is less than the surge impedance loading, then it will act as a source of the reactive power. And whenever the amount of load is greater than the surge impedance loading, then it will act as a sink of the reactive power. The next important device is underground cables. As we already know, always the underground cables which having a large amount of capacitance. Okay, so it is a characteristics of cables. Already we studied that the concepts in the previous. So due to this high capacitance, always as we already know, the capacitor which acts as a source of the reactive power. So due to resulting in always the underground cables which supplies the reactive power. The next important device is the transformer. The transformer, the basic characteristics of transformer, the transformer having both primary and as well as secondary winding, which are inductive in nature. So always the inductive loads which takes or which absorbs the reactive power. So always the transformers which act as a sink of the reactive power, or we can say that always the transformer which absorbs the reactive power. Next one, load. So here the loads in a practical power system network, the loads are of inductive type only in most of the applications. So always the inductive loads are inductive type of loads which takes the reactive power. So the loads are usually absorbs the reactive power. Heavy lagging load causes severe voltage drop. That is why the reason why the voltage drops, which is going to be occur frequently in the power system network, is it is due to the high lagging loads of the given power system network. That means that whenever the loads are of high lagging loads, if we have high inductive nature, if we have, then it takes the reactive power and due to resulting in the sudden drops in the voltage or sudden drop in the voltage which is going to be happen. And next, the compensating devices. Compensating device, there are so many compensating devices we have. These are added to either generator which absorb the reactive power, and they are controlled to balance the reactive power which is desired. So there are what are the compensating devices and how these compensating devices which will going to be control the reactive power in the forthcoming sessions we will discuss. Okay. Next, we'll discuss about methods of voltage control. So in what methods that we can control the voltage? The control of voltage at all levels can be done by controlling the reactive power flow only. There is a correlation between the amount of reactive power flow in the power system network and as well as the voltage. So always the control of voltage in the power system network, which is done by the controlling the reactive power flow in the power system network only. So while the generating units are equipped with AVRs, other control methods are used throughout the system. So the devices which we are using in the practical power system network, which are given below. So by making use of the line reactance compensators, we can control the amount of voltage, or we can say that by controlling the reactive power flow. So this is one of the important type of compensating method we are using in the practical power system network. So this is line reactance compensators. Both we are using series here in this case we are using the series capacitors to control. Next, shunt reactors and as well as the capacitors. So here in shunt to the transmission system, we are going to connect the reactors and as well as the capacitors. So the reactors always which act as a sink of the reactive power, and always the capacitors which act as a source of the reactive power. Next, synchronous condenser. So what is meant by this synchronous condenser? An overexcited synchronous generator, which is called as a synchronous condenser. So this is always an overexcited synchronous generator which always delivers the reactive power. So synchronous condenser always act as a source of the reactive power. Okay. Next, regulating transformers like tap changing transformers and boosters. This is also one of the important technique that we have to control the voltage. And apart from this, we are using in the recent type of applications or in the recent type of power system networks, we are using the fax control device. Okay, that is the power electronics based flexible AC transmission systems, that is called as the fax device controller, which we are using in the recent days to control the voltage in the practical power system network. Okay, so with this I'm ending. In the next class, we'll derive the relation, what the dependence of voltage of and the reactive power that we will discuss. Thank you.